Makes
Yeah.
sense.
Yeah. Okay, chalo. Let's. I think the session should begin in some time. Yeah.
Right. Yeah.
Okay.
Yeah.
Okay.
Okay. Thanks. So, Shekhar, shall I start sharing my screen?
Yeah, you can keep the first slide on, right? And then we'll start off in about a minute more. Yeah.
Okay, but I need to share my desktop, right?
Yeah. Hemant, there is some, yeah, perfect, now visible.
Oh, there is actually a small challenge. My laptop screen is not working and I have to use the webcam from a laptop and I am using my monitor. So that is the reason. There might be a bit of drift.
No problem.
Yeah.
We talk about technology and then we kind of have these.
Yes, it's unavoidable. You know, when it comes to technology, it is certain that the more you need, there will be troubles and problems or challenges around it.
Absolutely.
Yeah.
All right, I think we'll start now, Hemant. So thanks a lot, Hemant, for actually coming over and gracing this platform, the FIRC Future Innovators Robotics Competition. So just for everyone, I'll introduce Hemant. So he's an engineering graduate, MBA from IITB and Washington U, a joint degree program completed in about December 2019. Total work of about 18 years. He's has worked with manufacturing and project management at Mars and Submiller. Rockwell Automation as domain expert for CPG and life science industry, which should be something very interesting to kind of hear about. He's made a humongous difference by claiming awards in Mars for process innovation, challenging status quo, never give up attitude. At work, he actually leads the global program, leading strategic alliance programs, develop instrumentation and automation strategies. And he's also prepared roadmap for digital manufacturing, smart factory using IoT, IIoT, analytic solutions. So welcome, Hemant, and I hand over the platform to you. And I'm sure that the next 45 minutes are going to be a lot of fun and learning for all of us. So over to you.
Yeah. Thanks, Shekhar, for the brief introduction. I know I will be touching upon a topic which most of the audience might find it, odd. They might not have experienced it that way because I have lived in the factories for my life and I'm a shop floor guy. So I love to be there standing and looking at machines. To start with, I can imagine way back in 2002, 2003, where I have started my career as a maintenance engineer. And looking at the age-old machines, and every now and then machines were breaking down, and without any intimation, without any information available around it. And now the way we are putting up this strategy in this era of IoT or Industry 4.0, how this thing seems to be changed drastically in such a short span of time. You might, the viewers might feel that 17, 18 years is not that short span of time, but if you really look at the history of global manufacturing, it spans down to now close to 150 to 200 years. So in that context, if you really see the way things have changed or moved drastically in last 15 years is tremendous when it comes to, really scaling back to the, what kind of time frame I'm talking about. And why we really talk about Industry 4.0 and all that, I'll be covering in the next topics. But my today's agenda would be, I will be talking a bit about overview of Rockwell automation, and then what kind of IoT, what does it mean? What kind of solutions when it comes to smart manufacturing that Rockwell does offer, and how we kind of go into and integrate into the existing manufacturing setups, and how do we actually help manufacturers to leverage the technology platforms for the benefit of their top line, their bottom line, and making everyone's life easier. So, and I'll be using a couple of technological use cases on analytics and AR. I know my earlier speakers in the forum has talked about AR and analytics from the context of designing it and how how the solutions are approached towards it. But I would be more putting up the use cases, how we are using those technologies and how we are putting them to the work into the manufacturing domain per se, because these technologies might find their use in multiple ways and multiple places. But my today's focus would be bringing those technologies onto the shop floor and making the life easier for everyone associated with the manufacturing operations altogether. So a brief about Rockwell Automation. Rockwell Automation is a global automation leader when it comes to industrial automation. We are 6.7 billion closely organization. We are operating into 100 plus companies, 23,000 plus employees, and we have the solutions which spans from shop floor to the top floor. That is in the terms of ISA, that is International Automation Society, we call it level 0 to level 4, wherein we have sensors and IO cards, PLCs at level 0, level 1, and then SCADA levels, SCADA softwares, historians, and further softwares to integrate that with MES and ERP platforms, which typically helps people to get a connected enterprise altogether, starting from shop floor to the top floor. Now, why I'm talking about connected enterprise, or why I'm trying to talk about connecting shop floor to the top floor, there is certain reasons associated with these terminologies. Reasons are pretty simple. Till some time back, maybe couple of years, 2015, 16, even in today's scenario as well, couple of industries or many of the Indian manufacturers still have legacy kind of automation solutions. And when I say legacy, it is that machines or equipments are automated using the help of PLCs or controllers, but so to say they are not integrated. They don't talk to each other. What does that mean? It means a lot when it comes to automation and automation strategies. Reason is very simple. If machine don't talk to any other machine, and if I am not able to access that machine, access the data and access the information which is coming from that machine, then I won't be able to take a real-time decisions based on that. And the today's context, what IoT or Industry 4.0 is talking about is, it is all about taking a real-time decision. Instead of doing a post-mortem shift report analysis and doing nothing about it. To be very honest, we have generated logbooks. At that age, we used to write everything in the logbook. Someone else would come next day, he will push those logbooks data into Excel. Someone do some errors, XYZ reports would be created, half a day gone. And when it goes for analysis, someone finds that data is not correct. Someone has done intentionally, someone has done unintentionally by mistake and things like that. And hence our whole purpose of generating that report has been lost, because at the end of the day, business is not able to take any call or any decision on that data, what happened. But the paradigm is getting shifted. The status quo of running business that way is getting challenged, and that is what is IoT all about, which I'll be covering into the next slides. But before that, why such an emphasis of all the global manufacturing community, at least per se, onto this particular initiative? It has been talked a lot in last couple of years, 4 or 5 years. But when people started to put around what kind of real benefits in terms of numbers, because if numbers don't throw away the value, then it's just it's just an initiative, someone is trying to sell something. But these are the credentials and data which has been established by well-known consulting firms like McKinsey's of the world, and they talk about kind of 4 trillion value which is going to be added to the manufacturing because of IoT or IoT solutions deployment by 2025. What does that mean? That means a lot, because today we are not even our Indian GDP numbers. If we really see, we are not even there. So we can imagine what kind of context which we are talking about. We are talking about 2 times performance improvements. Today, if my plant utilization after such a big investment is not going to go beyond 40, 50, 60%, then what kind of losses I'm incurring too. And it actually kills away the bottom line of the business. And obviously it is going to help companies to improve the top line. That is their 40% of operating income which are going to be improved. And all of these businesses are going to be competitive, because in today's world everyone want to be competitive, to be really meeting the customer expectation, meeting the customer service levels and the deadlines be ahead. And how does these technologies came in the forefront? These are the I have noted couple of top 10 technologies which are actually spearheading the industrial revolution. What does that mean? This was the information which I have captured in 2018 January. Mr. Amitabh Kant, who is CEO of Niti Aayog, in one of his articles, he has mentioned all of his thoughts around these technologies. And when we sit through and think about, does it really mean so? But yes, then we have to accept that yes, these are the real technologies which are going to be deployed into the manufacturing. And that is the reason this Industry 4.0 is talked about as a fourth industrial revolution, which has happened in the history of the manufacturing. So I'll not get into the details of each and every one, but Rockwell also understand this in much detailed way. And henceforth, Rockwell has also developed product, services, and solutions around these technology, utilizing these technologies to help manufacturers deploy these solutions and reap the benefits of this fourth industrial revolution, wherein their businesses would be benefited tremendously out of it. So this actually is a very interesting story, and I'm very sure that from the audience, everyone might have heard this story in some way or the other in their childhood. And I can correlate the same phenomena or same story very precisely with IIoT or Industry 4.0 thought process when it comes to deploying it, or when it comes to understanding it all together. And this is what is my experience, because I interact a lot with Indian manufacturers, typically from CPG and life science industry per se, because I work focusedly on these two industries. But we find these interesting thoughts coming over from each and every one. People just think that whatever area they are experiencing, that is something, if they do something there, then they would be able to deploy this solution. But unfortunately that is not the case, and IoT or Industry 4.0 is much beyond this story. And this is a slide which talks about how the manufacturing revolution was started way back in 1850, and so far we have experienced different kind of electrical motor, then computer ingestion into the manufacturing, and these kind of revolutions. And today when we are talking about globalization kind of scenarios, regionalization, and even personalization sort of scenario, where people are talking about building product from your personal choice, and that kind of speed and that kind of agility which is expected from every manufacturers out there. And everyone is struggling to meet the customer's expectation, because the business has become that much competitive and cutthroat. So this was all about my understanding from the overall business perspective. And I would now get into the shop floor or the manufacturing part of it. And it is a hardcore controls and automation kind of discussion. Please bear with me, or don't hesitate to stop me and get things clarified there itself, because there will be a lot of jargons which I might use, and as a viewer you might find it difficult to connect with those things. As Rockwell Automation, we talk about connecting the complete enterprise, which I have already said. So what does that mean? It means every factory or every plant, all the vendors, every complete supply chain is connected and visible. And is it possible? Yes, very well possible. And Rockwell does have all the solutions pertaining to automation, pertaining to electrical, intelligent motor controls, drives kind of solutions, and then subsequently supporting solutions and services to address this requirement. Now, when we say Industry 4.0, what exactly do we talk about? We talk about making the manufacturing smarter. And why do we want to do that? There are so many reasons which we have already discussed. How do we make the manufacturing smart? It is not a tablet that is available that you take it and you are smarter. No. What do we need to do? I have already talked about creating the islands of the automation. And every machine is having their own controls, but they don't talk to each other. But what does the machine throw? Machine throws the real-time data which is available with the machine itself. What kind of voltage, power consumptions, current, running time, uptime, downtime, process parameters which are coming from that particular machine. But do we think that anyone would be able to take any decision based on only looking at the data? Unfortunately, the answer is no. And why? Because if the data is available in abundance in front of us, the data volume which I'm talking about is every kind of 500 milliseconds data. That is every second there will be 2 entries for these many data coming from each machine. And if I take even a medium scale kind of manufacturing setup, there will be at least 50 equipments or more than that of such nature. So you can imagine what kind of amount of data management or data handling which we are talking about. If it is so for one machine, then still someone might get into that and try to understand it. But when we put across such a humongous kind of data which is being thrown us at such a big speed, it is not really possible. Then how do we do that? We actually have the solutions to provide context to the data which has been thrown to us by the process equipments, by the packaging machines, primary area, secondary area, and all of that. And what do we do out of it? There are certain KPIs or KRAs from a business perspective for a manufacturing plant. Everyone wants to track the energy consumptions, per product energy consumption, per product cost of it, per product OE. What is the OE? What is the downtime? Because at the end of the day, what matters is how much was the throughput from that particular line or particular plant, because that is where the top line is going to come from. If I'm not able to produce, then I'm not able to sell it that into the market. So after these contextualizing, then information that is available with us, now we can take this information and with our experience we can apply analytics over that information. And that is the beauty of the solutions which are available, which um, I'm confident that many people have already talked about, utilizing the data analyst, data scientist, creating those analytics kind of algorithms and solutions, and then predicting what is going to happen next based on the test data or the past history data which is available, and that sort of solutions which are expected to make the machine smarter. So we actually deploy these kind of solutions, and then we don't stop there, but we also kind of provide wisdom for the machine that it will actually help operator to take decisions or guide operator to take decisions faster in the real time, instead of waiting for post facto kind of analysis of that. So here I have taken that.
Hemant, sorry, just I had one question while you were just walking through that, right? So
Right.
all this data is actually real-time data, right? So how do you actually ensure, like all the points of data collection are actually working in order for you to get the data real-time? That's one. And two, how do you integrate bringing all of this together? Analytics and wisdom can be put on top of it once you have the data and you know what you're monitoring, right? But
Right.
how do you actually get all the data and how do you integrate it? I think that will be a very, if you can just use a use case over here in terms of a machine or something that you've implemented,
Yes.
that will be great.
Thanks, Shekhar, for asking that question. Every machine would be having the controller or PLC. Right now, I'm trying to point it to that. You might be able to see that to control it. So all of this data actually comes from the inputs and outputs which are actually machine is controlling. So right now, with the help of technologies, we are able to connect these controllers as a part of the control, as a part of the Ethernet network or central network for the plant. And with help of Rockwell's software products, which typically helps us to get this data from these controllers and then provide context to it and provide, take that data to the IoT platform where we do have analytics uh, products and solutions which actually will help us to predict whether this machine is going to fail in certain time, because for a bearing to fail in 10 hours, in the past also similar situation has arisen, and bearings won't be failing all of a sudden, right? There will be certain small drift which will start coming, there will be certain noise which will, or vibrations which starts going up, the motor load currents will also start going up, and the speed or the rate will be very slow and steady. But over a period of time, when that gets built up, it will further get deteriorated, and on one fine day it will fail. So what typically these analytics products and solutions do is they will take that historical data of machines normal operating conditions and machines failure which are already recorded into the database, which would be available at this controller level and at the historians which are part of control systems. We can make use of those data, and with the help of these softwares and these solutions, we can create these algorithm and create these predictions. If current keep on going after certain limit and for this particular time frame, if the temperature keeps on rising, if the vibration keeps on going high and it crosses this clip limits, then it is certain that in XYZ time frame that motor is going to fail or bearing is going to fail. So that is how we actually make these use of these solutions and help operator to be smarter. And it is not that operators are not smart. I have seen myself that one operator is able to, he has got such a good hold and good control on the machine that he is able to say that, this machine is having some problem, it is going to fail some XYZ, but not all. And you cannot rely on one operator, because you just have to imagine there are so many machines, and operators will also be coming into shifts because the plants would be operating 24/7, and that is where all together it doesn't make any sense to depend on only one person and his experience or knowledge. That is what we are actually trying to do. We are trying to build this expertise into the machine itself so that it doesn't become so person dependent, and the machine itself can guide us or guide anyone who is operating that machine to take those decisions and to make it efficient. So it is all about it. Hope I have answered the question, Shekhar.
Absolutely. Thank you for that, Hemant. It was very
Yeah,
nice answer.
yeah, yeah. So this is a typical scenario which I have tried to look at, which we have already discussed. In line ones, let us take an example or case that line 1 pump 3 is having some problem or it is maintenance due. So how does that one operator come to know? Because in a medium size plant as well, there will be thousands of motors, minimum 1000 to 1200 motors would be there. So how does an operator or a technician know that which pump is creating problem? But with these kind of solutions, he can get alerts and prompts as and when the maintenances are due, based on our algorithms or programs which we do. Based on the energy usage also we can track that, and also the yields, whatever production yields which are expected from a particular equipment, that can also be tracked, and the operator or the technician will be having all of these data or information available to him in the real time. And that is what we call about smart kind of manufacturing setups. And here you can see we have created a condition as well. The equipment is coming to the end of its cleaning cycle. So it is popping up to the operator that, come and do my cleaning. It's due. It's going to be due in next shift. And why it is altogether important, it is not that you don't want to clean the equipment, but imagine a situation where my plant is running and all of a sudden it gets a breakdown. All of a sudden, the equipment has to be cleaned. If you don't clean, then it actually, can create a quality issue. Because many times you take a case of food manufacturing or a pharma manufacturing, there are certain cycles. Maybe you can run a clean equipment for 12 hours or 24 hours. After that, you have to run a cleaning cycle, and then only you can again restart the operations. If you can, the information or input in advance, you can plan your production accordingly. What happens if in a running batch, if machine fails, if you have to stop the production and do the cleaning, then you can imagine what kind of impact it is going to have on overall productivity from that plant or from that equipment. And in real time, in any plant, there are not standbys for everything, because these equipment should be that costly that you don't want to keep standby for standby and replacement for replacement. And from that perspective, it actually affects the overall productivity when it comes to output of the plant. So, and if I don't want to land up into that trouble, it is better that my machines start pushing me the alerts, I'm going to fail, please do something. Then in the event of break, instead of waiting for a breakdown, we can plan a smaller shutdown which will not cost that much, and get the things back on track. So these are different kind of scenario. Some machine is sending you alert, some temperature sensor is telling you that I'm not up to the level, I need some more time. So what is that happening? It is going to take more time, means your batch cycle times, which we typically call it in terms of manufacturing, goes higher, and obviously reducing my daily production hours or daily production output from the plant, which obviously we don't want to encounter too. So till now I was trying to explain the manufacturing scenarios and the different kind of technologies and solutions which are available. In these two cases, I will explain how these solutions are actually put to the use into the industry. Because designing and talking about these solutions is a different thing, and putting that into the real use, or I would say we most of the time we use the term called use case, that becomes all the more important and more relevant from that perspective. So from the analytics perspective, if I have to talk about, this is the precursor of the system. That is, these are the current systems which actually indicate you what happened. What do I mean by that? If suppose a pump is running, and if the basic automation is provided to the pump, what happens is, when the pump gets tripped, operator gets an alarm on his SCADA that XYZ pump has tripped. And what does that means? It means it is going to need this much amount of human input and decision making to take an action to make the pump or the system back to the operation. Wherein against the next level of analytics solutions which we talk about is, why did it happen? So we go one step ahead and we actually guide operator or a technician that this was a reason out of 3, 4, 5 reasons which might have encountered, might have experienced before. And then operator actually gets a decision support. He actually don't need to spend a whole time around analyzing the situation and coming back to a decision point and take some action. So we are trying to reduce the human inputs and the time taken to analyze the situation and the reason behind it. And now the advanced analytics solutions which Rockwell and PTC has jointly developed, and which are a very well part of the IoT journey, they actually are becoming more proactive. They actually predict when something is going to happen. So typically operator is very well in advance being intimated when the downtime is going to happen. So what kind of decision I need to take? I need to do it faster. Still, it calls for a human decision, but kind of amount of time that human intervention is expected or required has been reduced drastically. And in the prescriptive stage, when I move down, there are further two layers to it. Either it is a decision support, that is, this is going to happen. You start taking care of this particular uh, bearing temperature. This bearing temperature is increasing. That is something called decision support, where operator just need to take that decision and take the subsequent action. And otherwise also the machine itself can take its own call. This is a further level of analytics automation. That system will create an alert, create a maintenance order, and it will land up onto the technician and things like that. So we can walk down to that extent or that level of the decision support and action. And as I was mentioning, up to few years before, it was not possible. It was not the scenario. And had it been take a case of 2005 or 2006, I would not have imagined that this kind of situation is going to be there 10 years down the line. But this is the reality, and that is what they call it. There are some exponential growth of technological developments, and that is what we are actually experiencing it. Hope it was clear so far, Shekhar and audience, and if there are any questions, please do post.
No, I think this is very good, Hemant. It's in the right direction. Thank you.
Yeah. And then we are talking about the same information, but in the context of line, and in the context of equipment. So whatever inputs I have talked about, if we apply it to a particular device, particular system, and obviously up to the enterprise level as well. So we do have solutions when it comes to all the four categories: descriptive, diagnostic, predictive, and prescriptive. And you can see at the enterprise level what kind of decision support it is going to help us. If I do the only descriptive kind of situation, I can at the max talk about which facility is better in terms of its performance. I can do the benchmarking, not beyond that. But when we go to the diagnostic kind of era, we can talk about where are we right now, how much is improvement that we need to do, what kind of actions that we might need to do. And in the predictive era, we will be alerted, and we can start working on plan B or side B to really boost up the production plans. So this is all about how do we kind of deploy the analytics to a manufacturing setup. I will be walking through a video here, but I'll have to. Last year, production bottlenecks in so hope this video is visible, Shekhar.
Yes, absolutely.
Yeah. So here in this case, I will be demonstrating or talking about a predictive maintenance use case, because so far I have talked and I have tried to explain the scenario, but when I thought when I walk you through the actual use case and how does it is going to alert the users and what kind of inputs it can generate. So that is what it will be, a kind of real-time test or real demo sort of scenario. I'll just push it to a bit. Yes. Now you can imagine we are trying to apply this analytics solution on this pump, and this pump has got all of these instrumentation which is needed to support the maintenance requirement. And we have installed vibration sensors, flow switches, flow sensors, and all the instrumentation. What we are trying to do here is we are trying to create a blockage or create a scenario. But before getting into that, we have taken the all past history data of a particular pump, and we have tried to create a model around it. That is what is we call it, this is the pump's normal operating condition. Here you can see the what are the critical parameters for a pump to function normally. It is the vibration levels, it is the discharge pressures, discharge temperature, and it is the efficiency. These parameters, these inputs we have modeled based on the flow rates and based on the current amperes or the load which has been taken by the motor of the pump. So you can imagine, you can see here the model is actually showing us at what efficiency the pump is running right now. And what is we are going to do here is we are going to create a blockage into the output of the pump, just to show you that what kind of changes that is going to happen to the particular parameters which are going to get affected and which will in tune affect the performance or efficiency of the pump. You can see the current scenario which is being shown here. Bearing is at normal, mechanical seal normal, impeller is doing its normal function. The efficiency, if you really see, we are operating at the maximum efficiency. So we will create a small diversion here into the output of the pump, and then we'll see that how the parameters gets affected and how the model starts giving these alerts. And here you can see based on those parameters and inputs, it is also predicting how much time to failure, mechanical risk. So we are going to create a scenario of flow reduction by operating the output valve of the pump, but then system does not know what is happening, and then system start reacting. And here you can see the mechanical risk failure, bearing risk failure is coming down. The impeller risk of breaking down is 6 days to failure, which was not the case. And the pump efficiency has been drastically reduced because the machine is assuming that all of a sudden the flow rate has been dropped drastically, and there must be one or the other reason, which is actually the real reason could be the impeller, which might have broken and which is actually causing the output to get reduced. See, the discharge pressure and then suction pressure, all of these are also affected because of the output flow rate issue, and then efficiency has been dropped drastically. And this is the alert which we are talking about. What happened? This is the alert which we are talking about. The operator is going to get. And imagine a real-time situation. If I, as an operator or a plant technician or a plant engineering manager, don't know which pump is going to happen and going to be going into the failure mode, what would be the scenario when the actual batch would be running? It is going to take at least couple of hours for any technician to come and either replace the pump or either replace the impeller on the shop floor, and which might cause for a batch to be discarded. And the second scenario is for this pump misalignment. Again, we are going to do the same thing. We are going to misalign the pump with the help of preset attachment to the pump. And these are the very common things which happens in day-to-day life of a manufacturing plant. See, now here you can see the vibration has gone high. The vibration reading are going up, and then mechanical seal failure days has come down to 11 days from earlier from 61 365 days, and then efficiency has also been dropped to 41%. And you can see from all of these equipments which are on the automation, all of these are being shown as their current statuses or condition, how much time they are going to get failed, and what location and those details. So this is the predictive maintenance use case which we are talking about. And then what kind of outcomes which are we are expecting from deploying this kind of solution. The most important is predictive maintenance, this anomaly detection, because these kind of anomalies, if don't get detected, then one day or the other they are going to end up into the breakdowns, and which actually affects the KPIs, our KPIs. And from that perspective, these are kind of solutions which we are taking it to our customers. And then from the augmented reality perspective, a lot is already been talked about augmented reality when it comes to, but what exactly augmented or mixed reality or virtual reality kind of scenario, and how we are able to utilize that into the manufacturing perspective or manufacturing. So everyone is aware about the digital and physical world kind of scenario, and then human physical experience and human digital experience, and how difficult it is for us if it is not mixed to follow it all together. I think we might have experienced it while driving and trying to drive on the Google Maps. But what if we can augment all of these, converge both these experience, and then what kind of ease and decision making it will help us to take a call quickly instead of looking at two places and trying to correlate both the things. So this is what we talk about this AR solution. And AR solution is again digitalization. These are the use cases into manufacturing. What we have done is we have used this PTC platform, Vuforia Studio, and we have created, we need to build these inputs or models into the platform, and once they are done, the operators can be guided to really look at the systems, and you would be thrown away with the real-time information which is available. If we don't do it this way, then we might have to look at different systems, because for energy there will be different system. For mechanical system, you have to actually get inside the machine and look at different gauges or parameters for their actual values. Some of these inputs may not be read directly, so you have to interpret them differently using some kind of Excel tools or some kind of calculators around it. But with the help of AR technology, and which we are trying to take it into the manufacturing shop floor, these kind of ease and access it is going to provide to the operators, which is going to be completely different kind of experience for anyone who is trying to run a machine or run a plant, because then the information or inputs are available at their fingertips. They don't need to look at anywhere. And typically these kind of solutions are obviously at very initial stages. They are being deployed at very selective and very specific spaces, because it calls for a kind of expertise, which I'm going to talk about, what kind of new job avenues which IoT is going to open up for upcoming engineers. And at least I find it really exciting, because I have never seen these kind of technologies into action while I was working onto the plant. And at least I feel, feel excited about when we see, we can do so many things about it, about machines and plants. So if you walk through the shop floor or the plant floor, you will be able to, monitor all of these inputs or parameters over a particular equipment or particular machine. And you don't need to really get into what data, where, what manuals, and those details. It is available readily. I'll just a bit. I think I'm going to be short on time, so
Yeah, let's rush through it a little bit.
I'll have to rush through a bit. Yeah. So these are actual models or digital twins per se, which we almost everyone talks about these days. And then so when it comes to augmented reality kind of benefits or values across the enterprise, here these are some of the benefits which we have recorded. But majorly on the design and the manufacturing front, and then the training part, these are going to be very useful. And when it comes to service, it is going to help people use their expertise without even need of traveling to the remote sites. And someone sitting in, say, Europe as a OEM or a OEM engineer can help you, working on the machine or equipment in India. So that kind of capability the technology is going to provide us. And this is again one more a small video of what kind of workflow. Here it is not. It is actually system is guiding for the operator to follow certain steps to complete his task. These workflows are very important when it comes to execution of very business critical kind of issues. And obviously AR is also helping us to deliver these things. And why it becomes important, I can take a case of life science or a pharma factory where all of these workflows are critical to be critically followed because of the regulations requirement. If operator does any mistakes into these following these steps, then it can actually create a big I would say warning letter which is coming from US FDA, because then the actions are going to affect the product quality per se of the finished good, and which is not expected in terms of pharma or life science product altogether. So from that perspective, these kind of solutions are very important to be, and they are really proving useful from a new training new people and new technicians as well. So it is on the same lines of mixed reality or AR. Here they are trying to use this to test the engine and engine parameters using the AR kind of solutions. Instead of looking at so many data and so many inputs or manuals, they would be guided through using those HoloLenses or some of the other technologies which are available. So here the quality person is actually checking the quality parameters of that particular engine which has been built. Not just looking at the lot of data or inputs. He's just looking at the HoloLens and he's guided by one by one for the parameters. So coming to the, I think I am going to be delayed by a few minutes, but I believe these are some of the exciting kind of career avenues or options that technology brings on the table. Uh, so if you got any question, anything, any clarification,
Uh,
probably we can open for the discussion.
yeah, Hemant, I think this is a very good insight of how you manage machines in the modern world going forward.
Yeah.
One key question that comes up is, everyone would like to have such a shop floor, which is like completely automatic. And, I would love to kind of implement that even in my own company also, right? All data coming to you real time, and I'm able to see who's doing what and stuff like that, right? But, the key critical thing I think is, one is how do you identify the data points, right? Then how do you customize the data points, and then how do you ensure that this technology sits on top of those data points to be able to provide data? Because one is that it becomes a very expensive affair, and then how do you see that paying you off over a period of time? You mentioned 40% or 4 trillion coming back to the industry, but it's obviously a big deterrent for anyone to step into it and say, let's implement it at the level that you've just shown us, right? So how does one balance returns while trying to implement this technology?
Uh, uh, sure, Shekhar. Um, Probably that is one of the complicated question which you have asked so far. But yes, we do encounter similar kind of questions or queries whenever we talk about these kind of solutions, because these are going to transform the way you work all together, and obviously it calls for a big investment. And can anyone afford to do it in day one and get away? No, it doesn't work that way. To be very honest with you, the way we work is we actually help or work with end user to identify these key areas or the key concerns or key KPIs which they want to address altogether. We at Rockwell's team or our partners team, we work collaboratively with customer, identify the gaps, and we actually formulate a strategy around how do we digitalize whole thing in phased manner, because doing everything in one go is also not going to work. It calls for a big kind of change management kind of initiative or action that needs to be taken. If I go and change everything, probably tomorrow the business is not going to run, because we don't know how to run that whole setup, right? And that is where we always take a kind of phased approach. We always recommend phased sort of approach. Take so identify critical pieces, go piece by piece, but with keeping a end in our mind, that we want to go here. How do we take a stepwise approach and formulate a phase-wise plan to identify data point for one particular machine, which will actually address the particular KPIs, and that is how the ROIs would be associated, ROIs or returns would be calculated. And based on that, once we complete the all of these phases, we actually deliver the whole digitalized kind of enterprise solution, and whatever outputs we have seen, we can look out for them.
Great. So there's
Yeah.
one question: how a cyber physical system actually works in smart manufacturing, and how it will be helpful in desalination plant.
Desalination plant, probably I would like to connect from a detailing perspective. But when it comes to cyber physical systems, from that perspective, yes, these solutions are both, or rather, they are available in all the models. One is on-prem, that is, we will be installing the servers on premises, the servers and data center in control of your own, or on the cloud as well. Our cloud or your third-party cloud like Azure or AWS. So we can host these solutions there also. And the third will be the hybrid kind of model where these will be at both the places. But whatever we do, the cyber security and those things are already taken care of. We also understand the cyber security challenges and threats which are going to come, which everyone is aware one way or the other. There are going to be challenges when it comes to cyber security. But yes, those can be addressed appropriately because these solutions are built and developed keeping in mind this customer requirement. Someone typically the manufacturing mindset is quite conservative. They don't want to put the data into someone else's control. Even when I was managing the project, I can imagine we did not wanted to let this shop floor and the communication network to be converged or mixed. We always wanted to keep them separate from these cyber security threat perspective, so that no one comes in and push a USB and something happens into the whole network. And obviously there are certain incidents, cyber security incidences, and people had paid people were asked made to pay ransom to make the plants operational also. But those things are, we understand that the Rockwell products and solutions, we do have a dedicated cyber security team who work with our project delivery teams, and we deploy the solution in cyber security safe way as well.
Yeah, Hemant, I think we're just up for time, just in time. So really,
Yeah.
really thank you for this wonderful
Yeah.
session.
Yeah.
Yeah, Ashwin.
Yeah, and in fact, this last slide probably couple of points which I have tried to put in, because I understand there are going to, the kids or upcoming engineers who are listening to this conversation, and they might be interested to look at, what kind of avenues or, areas where do we look out for, or, what kind of opportunities does it offer. So in my own opinion, these kind of, opportunities that definitely are there from a career perspective.
Yeah.
This is really interesting for everybody who is watching this. And yeah. So Hemant, I was extremely occupied going through your entire presentation, understanding how technology with all this automation is bringing in a paradigm shift in the manufacturing process. And as you rightly pointed out a few minutes back, still the manufacturing hubs in India are quite conservative to adapt these changes, but I am sure that sooner or later they will realize the importance of turning on towards the automation of their entire manufacturing plant and eventually increasing the efficiency of their entire working plant, so that they can work with more and more efficiencies, increasing their revenues as well as profits.
Yeah,
Uh,
in fact, Ashwin, I would like to add, why young talent should think of manufacturing as a good career option is there are two reasons to it. One is this Atmanirbhar India,
yeah,
and the other is the Make in India. You
okay,
know, if these things are going to happen, there would be ample of investment that is would be coming to us in
okay,
terms of manufacturing,
yeah,
and it would throw us these kind of opportunities in abundance. So,
okay,
so, so we need to be really, preparing ourselves, getting ready, or making us fully prepared from that perspective as well. That is my opinion or my view.
okay. I'm sure we will be riding high on the wave of Atmanirbhar India.
Exactly.
So
Exactly.
Mr. Nilesh has one question here.
Yeah.
How can small and medium enterprises get access to Rockwell Automation's technologies, and how can it be implemented?
Yes, we do work with small and medium enterprises as well. Rockwell has got dual kind of working model when it comes to working with customers. You can directly contact us to deploy some or any of these solutions, or not only these, even the basic automation we can start with. And also Rockwell has got a lot of partners. We call them recognized system integrators, who takes Rockwell's products and are capable enough to develop applications and solutions suited for the requirement from the application perspective. Because many a times these automation solutions would go into as an industry specific. From oil and gas perspective, there are people who know oil and gas better. From a CPG license perspective, there are people who know CPG license better. So from that point of view, yes, we work day in day out with all small, medium, and large kind of customers, and you can approach us, and we can work jointly with you to really identify what's and how's which are going to be. We can help you prioritize the investments or automation opportunities, and help you to deploy these solutions as well.
Okay.
Yeah.
Hemant, I have one last question from my end as well, considering the audience that we are catering to currently.
Yeah.
how can like any of the first teams from India, like any first Lego League or a first Tech Challenge teams from India reach out to you or your team so that they can seek out some technical help wherever they need it? Like, you know, this has been like quite a good practice in United States and other countries. But looking at the awareness that is coming in for the Indian teams as well now, I'm sure like companies like Rockwell Automation and PTC will play a good role in curating that interest among the students for these competitions.
Yeah, in fact, I recollect the FLL 2018 winners. They were invited into the Rockwell's event in Delhi.
Okay.
And we definitely encourage students as well to approach us and then kind of guide them if they are interested, and they were allowed to set up the stall, and then a lot of buzz around was also there from that
Okay.
perspective. So we obviously if anyone is interested, definitely you can reach out to me, and I will if needed then guide to the right channel or right person.
This can be a very good thing. Like we never knew like this was done. So it's a
Yeah,
very
this was already done, which I am very well aware about that, and probably Nilesh also might be.
okay.
Yeah.
Great. Thank you. Really, really appreciate your time, Hemant, for this. And thank you for the session today. And I'm sure that we'll reach out to you soon in the future, in the near future, for us to be able to connect and work on different kind of things then.
Yeah, I would also like to thank you and FIRC and FLL FTC platform for inviting me and allowing me this opportunity to present, present manufacturing case, I would say, which is my passion altogether.
Yeah.
I always wanted to be on shop floor, and somewhere or the other I am on the shop floor. I really enjoy and cherish that.
Great. Great.
Great.
Thank you for your time, Hemant. Thank you.
Yeah,
Thank you
thanks.
all for your time. And we'll meet again at 6 o'clock tomorrow. Tomorrow, we've got Mr. Vihan Shah, who will actually be talking about gamification and careers in gamification, which is one of the sunrise industries over the next decade or so. So thank you, everyone. Thank you for your time. See you. Bye-bye. Thank you, Hemant.
Thank
See
you,
you.
Yeah,
everyone. Thank you, Hemant. Thank you.
yeah, thanks everyone. Thanks.